Welcome to Printing with Visual Basic. This video will show you how to print lines, characters, columns of data, and images using Visual Basic while creating a sample Paycheck program that has a paycheck and a pay stub. The development for the Paycheck program can be done in two parts. Part 1 is on the main form, which is going to read the name, number of hours worked, and the pay rate, and compute the paycheck, the deductions, and the final net pay. You need to complete Part 1 before you do Part 2. Part 2 has the print preview and the print, which uses the data that was created in Part 1. When the Compute Pay button is clicked, the program computes and displays the number of hours, overtime hours, payment for each, and the gross pay, which is paid before deductions. The program is also to compute deductions, which include federal and state withholding, disability insurance, called SDI in California, Social Security, called FICA, and the program displays the total deductions and the net pay, which is pay after deductions. The Clear button clears the name, hours, pay rate, and the list box, which is used to display pay stub. The Exit button quits the program. In Part 2, the Print Preview button displays a preview of what the paycheck and pay stub will look like when printed. The Print button causes the paycheck to be printed. Here's an overview of how the program works. The Compute Pay button reads the name, the hours, and the pay rate, and computes the pay. The Print Preview button shows a print preview screen with the paycheck and a pay stub. The Print button actually prints out the paycheck and the pay stub. Let's look at Part 1, the main form. Labels and text boxes are used to input the employee name, hours worked, and the pay rate. Make the list box big enough to hold the paycheck summary information for the pay stub. Adjust the size as needed when you test the program. You may have to make it bigger or wider. And place the 5 buttons on the form. Use a monospace font for the list box. Windows provides several monospace fonts, such as Courier New, Lucidia Console, and Lucidia Sans Typewriter. These fonts use the exact same spacing for each letter. Monospace fonts are best to use when displaying data in columns. Look at the Arial font example. See how the numbers are kind of squiggling back and forth? Even though the number of spaces for both Lucidia Sans Console and Arial are the same, they just don't quite line up very well with the Arial font. Here's a comparison for the monospace versus proportional spaced fonts. The Lucidia Console has every character width the exact same size. The Arial is a proportional spaced font. Look at the letter I. On Arial, it's only as wide as it needs to be, whereas Lucidia Console makes the I exactly the same size as a character which is wider. Here's a comparison between sans serif and serif. The sans serif does not have any of those little extra lines on the characters. Compare the A. There's an extra line at the top and 2 little lines at the bottom. On B, the edges stick out on the left-hand side. We want to use a monospace font for the list box. After you've placed the list box on the form, make sure it's selected and click the button that has the 3 dots at the end of the font property to bring up the font dialog box. Select one of the monospaced fonts. Name each of the objects on the form that will be used when computing, displaying, and printing the paycheck. The labels used for the title, name, hours, and rate do not need to be given a Visual Basic name because they're not being used as part of the computation in the program. However, we do want to give names to the text box for TXT name, TXT hours, TXT rate, LST paycheck for the list box, BTN compute, BTN print preview, BTN print, BTN clear, and BTN exit. Double-click a blank area on the main form. Then, right where it says Public Class, let's start here. I'm defining constants for federal tax rate, state tax rate, SDI tax rate, and FICA tax rate. For example, the constant for federal tax rate starts as CONST, Fed tax rate as decimal equal 0.15. I also have a comment on the side, 15% federal income tax. That way, when somebody sees the 0.15, they know it's 15%. A little bit easier to understand that way. Do the same thing for state tax rate, SDI, and FICA. I've also declared a collection of global variables using the dim. I don't want to use const because I need to modify these variables as the program runs. So here's dim employee as string, dim hours as decimal, rate as decimal, reg hours as decimal, OT hours as decimal. I want to be able to separate the hours into regular hours and overtime hours. That way I can compute the regular pay and the overtime pay. By adding those two pays, I'll have the gross pay. Compute the federal tax by taking the gross pay and multiplying it by the constant federal tax rate. Do the same thing with state tax, SDI, FICA. Add up all the deductions for deductions, and then take the gross pay and subtract deductions, and that is your net pay. That's the pay after the deductions. Double-click an empty area on the form, and then double-click each button to create an empty event handler for each of the objects. By double-clicking a blank area on the form, we'll have an event handler for form load. This way, I'm going to have an event handler for form load, button compute click, button print preview, button print click, button clear click, and button exit click. Right now, they're all empty, but we'll start filling them in as time goes on. I need to put a subroutine call in each of the handlers. For the form load event, clear form. For the button compute click, we'll have a subroutine called compute pay. Just leave the print preview and the print blank for now because we'll fill these in when we do part 2. For button clear, go back and put another clear form. And for exit, that's an easy one, me.close. After the event handlers are filled in with the subroutine call, we need to go and write the subroutines for each of these things that are being used. Here's an easy one, the clear form subroutine. It's going to say private sub clear form txtname.text equals string.empty, and do the same thing for all of these. And then for the last one, lst paycheck.items.clear. This is a list box, so it has to be cleared a little bit differently. The clear form subroutine is called by both the form load and the button clear event handlers. It is much better to use a subroutine that is called in both places instead of having to duplicate the code twice. Part of the reason is you save a little bit on the coding, but the big reason, if new controls are added to the form and they need to clear stuff, there's only one place where the clearing is done. That's in the clear form subroutine. That way, if you have to modify that, there's only one place that you need to modify instead of more than one. Let's look at compute pay. The compute pay subroutine follows the sequence of input, process, output. What we'd like to do though is put everything inside of a try-catch block. That way if there's any errors while reading the text boxes or any errors while doing a compute pay, we can catch it with a catch. Here's the code for getting the data and separating the regular and overtime hours. Start off with the input. Remember we had declared employee as a string, so I'll say employee equals txtname.text, so I'm going to read the employee name out of the text box. Hours, I'm going to convert to decimal from txthours.text, and for the pay rate, rate equals cdec txtrate.text. Now I want to separate the hours. One thing I can do is make sure that the numbers are actually valid numbers. If this program is doing a paycheck computation for pay for a week, there's only 168 hours in a week. So you can't go over 168 and you can't go negative. So if hours is less than 0 or hours is greater than 168, then throw, new exception, illegal entry. Try again. And if hours is less than equal to 40, then regular hours equals hours, and the overtime equals 0, else regular hours equals 40, and the overtime equals hours minus 40. So that way, if you had 50 hours, regular hours would be 40, and the overtime hours would be 50 minus 40, which is 10, so then you'd have 10 hours of overtime. Let's take a closer look at how this works. For example, if I had 30 hours, which means no overtime, then here's 30 hours of regular pay and no overtime. So I'd have, if hours is less than or equal to 40, which is true, then regular hours equals 30 and the overtime hours equals 0. How about if I had 40 hours? Then I have regular is 40 and no overtime because hours is less than or equal to 40. How about if I worked 50 hours? In that case, I would have 40 regular hours and 10 hours of overtime. If hours is less than or equal to 40 fails, I'm going to come down and hit the else. So regular hours is equal to 40 and the overtime hours is equal to 50 minus 40, which is 10. Here is most of the code for displaying the gross pay and net pay. First thing I did was clear the list box. So I say lst paycheck.items.clear. Then lst paycheck.items.add string.format and then an open parentheses, quote hours colon, and then a whole bunch of spaces. I'm using string.format. It is very useful for getting text to line up in columns and specifying a column width and the number of decimal places to be displayed. String.format provides many of the features of the C language printf routine. Printf is also available in other languages such as C++, Java, PHP, Bash, etc. Now the arguments are placed after the closing quote, and the arguments start off as 0, argument 0, argument 1, and each one is separated by a comma. So looking inside the curly braces, it starts off and identifies the argument number, and then the field width, and then how the data is to be displayed. For example, open curly brace 0, comma, says argument 0, then 9 colon N2. It says I want a field width of 9 characters and I want to display a number with 2 decimal places. I could use C2 to display the similar thing with a $sign. Looking at this example, if I start off with lst paycheck.items.clear, then I want to add string.format into the list box. I'll say hours colon, and then the next one has pay rate colon, and I'll have enough spaces so that the open curly brace lines up. In the first one I'll display the hours, and then I'll display the pay rate. Then just go ahead and finish filling in all the rest of these things for regular pay, overtime pay, gross pay, and you'll be displaying the values that were computed earlier. One of the last things you need to do is you need to make sure that there are enough dashes and equal signs so that everything lines up on your screen. The next thing to do is test part 1. Complete the program and fix any errors, and then try a couple of things. Enter a name. I have 50 hours and a very nice pay rate of $60 an hour. Click the Compute Pay button and you should have the same values as shown here. Let's go on to part 2, in printing the paycheck. Set up Visual Basic to print. The Print Document tool gives Visual Basic the ability to print. Scroll the toolbox up or down until you locate the printing tools. Double-click Print Document. This will place a Print Document tool in the component tray. The component tray is located below the form in Visual Studio's design mode. We want to create an empty print document event handler by double-clicking the Print Document 1 object that's in the component tray. This will give you, in the code section, the ability to actually draw the printed page. The print preview is a little bit more complicated. So the print preview dialog tool gives Visual Basic the ability to perform a print preview. Do not use print preview control in this project. Double-click Print Preview Dialog. This will place the Print Preview Dialog tool in the component tray. While the Print Preview dialog is selected, use the pull-down arrow to select the document property to print document 1. This step is what connects the Print Preview to the object that is going to be printed. Now let's code the Print Preview event handler. Double-click the Print Preview button to bring up the event handler and enter this code. Print Preview Dialog 1, that has to be the same name as the tool that was placed in the component tray. So Print Preview Dialog 1 dot show dialog. That's going to bring up a dialog box when the Print Preview button is clicked. Now we need to figure out how to draw the paycheck. Since the printer and monitor are both graphic devices, everything that is to be printed by Visual Basic must be drawn, both lines and character strings. Lines are specified by an XY coordinate for each end of the line. Character strings are printed by identifying the string, font, brush, and XY coordinate of the upper leftmost coordinate of the string. Let's design the printout. Either use a pencil and paper to lay out the image of the check or print a sample of the printout that's available as a PDF image located on the class website. The check used in this demonstration is 6.5 inches wide by 2.75 inches tall. The check image starts at coordinates 1 inch by 1 inch. The check image starts at coordinates 1 inch, 1 inch. The coordinates for the upper left corner of the check start at 1 inch by 1 inch from the top of the page, which is in increments of 1/100 of an inch. So that means it would be 100, 100, which is 1 inch, 1 inch. The coordinates for each of the lines are identified by an XY pair. X1, Y1 for one point, and X2, Y2 for the other point. The 4 lines to draw the border of the check are identified as X1, Y1, X2, Y2, which comes out as 1 inch by 1 inch, which is 100, 100, and then, since the check is 6.5 inches wide, the coordinate for the right-hand top corner of the check is 7.5 inches by 1 inch. The next line is 7.5, 100. The next coordinate is 7.5 by 1 inch. Going around the check, I have 100, 100, 750, 100, 750, 100, 750, 375, 750, 375 by 100, 375, and then the last line is 100, 375 by 100, 100. There are several versions of the Visual Basic draw line method. The one used in this demonstration looks like this. I have a bunch of dims right here. I have dim black pen as pen equals pens.black. I need to create an object for my pen. Then I have dim x1, y1 as 100 and 100. This is the upper left-hand corner. And then dim x2, y2 as 100, 375. This is going to draw the line down the left-hand side. To draw that line, I can say E dot graphics dot draw line black pen, x1, y1, x2, y2. That will draw the line down the left-hand side. To make things a little bit easier for myself, what I'm doing is creating a two-dimensional array of integers to hold coordinates. To create this two-dimensional array, I'll say dim line array, open parentheses, close parentheses. That means I have a multi-dimensional array. As integer equals open curly brace. Then down here at the bottom is the closed curly brace. So inside I have a multi-dimensioned array. I have 100, 100, 100, 375, and then right here are the 4 lines for the border for the check. To go through this array, I'll just use a for loop. For I equals 0 to lineArray.getLength sub 0 minus 1. This is the length of how many elements are in the array. Now if I'd say length, I'd have the count of all of these, but if I say get length sub 0, that tells me how many elements are going down. So I have 1, 2, 3, 4, so that means I have 4 lines. For I equals 0 to lineArray.getLength sub 0 minus 1. I have to do the minus 1 because right here we're counting from 0 instead of 1. Then inside the for loop, e.graphics.dryLine, open parentheses, black pen, comma, line array I sub 0, comma, line array I sub 1, comma, line array I sub 2, comma, line array I sub 3. So that's going to pick up all the way across on the single line. Then the for loop is going to increment I to a 1. So I'll draw this then I'll draw the line with the coordinates on index position 1. And I'll do this all the way down. All you need to do to put more lines on the screen is add more lines into this array. Now, you have to put a comma right here after the 750, 100, 100, 100, You have to put a comma after the 750, 100, 100, 100, close curly brace so that you can add more data. The last one does not have a comma, but just put a comma right down so that you can get more data going down. Let's look at drawing text on the screen. I've defined 4 fonts. Here's font 10, that's the name I gave this font. Font 12, I gave another font, that one. Font 16 and font mono. So these are the names that I created. It says dim font 10 as font equals new font. This is going to be creating a font object. Arial, comma, 10, comma, font style dot regular. Similar for font 12. Do something similar for font 12. Arial 12, regular. Dim font 16 as font equals new font, quote Arial, quote, comma, 16, so that's going to be bigger, comma, font style dot bold. I'll use the font size 16 to print out the person's name, the date, the check number, the amount of the check on the big line, and the word non-negotiable. First thing I need to do is make sure the pay has been computed. Then let's look at drawing the check number. e.graphics.drawString, open parentheses, and then I have a quote 1234 quote, and that's my check number. If you wanted something different, then you could have a different check number there. Comma, font 16, which is size 16 bold. Brushes dot black, comma, 640, comma, 120. How did I get to 640, 120? That's 6.4 inches by 1.2 inches. That's where I wanted the check number to start. We have to remember that is the upper left-hand corner of the first character. Then let's draw the company name and address. I put Super Duper Inc. in size 12, and I put the address and the city in size 10. You need to complete the rest of the text that goes on the check.
Several asterisks are shown before and after the dollar amount on the paycheck. The drawString function right here only displays the amount of the net pay. How can we update the code to display the leading and trailing asterisks? The easiest way is to use the ampersand concatenate operator when drawing the string in 3 parts. First, put as many asterisks as you want. Use the ampersand operator to keep building a longer string that includes net pay, and then use the ampersand again to add more asterisks onto the string. The "C" on net pay to string places the currency symbol in front of the net pay. The currency symbol in the US is the $sign, the euro symbol in Europe, the pound symbol in the UK, the yen symbol in Japan, and so on. The selection of the currency symbol is determined by the Windows country or region setting. Here's a video on how to change the country or region setting.
How about drawing the image of the bank? I already have an image of a bank that's available on the class website. Now you can create your own image to be placed on the check. The size of the image should be approximately 100 by 55 pixels. The image can be provided as part of the program as a resource, or it can be loaded from the disk when the program starts. The problem of loading from the disk is that the image must be in the same folder as the exe file, or you have to specify the directory or folder for the program in order to find the image. So let's figure out how to do it as a resource. First thing you have to do is you have to have the image on your computer. For example, copy the image from the class website and put it on your desktop. When an image is included as a resource to the program, it actually becomes part of the exe file or part of the program itself. So get or create an image for the bank and save it to the disk. Then right up here on the top menu where it says Project, I want to say Project menu, and then go down to the bottom where it says Properties. Use the pull down arrow to select Image Resource, and then use the other pull down arrow to say Add Existing File. Find the file on your disk and select it. So I want to go to my desktop and find the file. Then the name of the resource will be used when you insert the image on the printout. Include this following line in your program: e.graphics.drawImage, open parentheses, my.resources.bank, and if that's what you named your resource was bank, comma, x, comma, y. Well, where the x and the y are the position of where the image is going to appear on your check. Now, let's draw the pay computation values. What I want to do is to copy the first 6 lines from the list box to column 1 and the last 7 lines from the list box to column 2. I'll show you how to copy the first 6 lines, and then you have to figure out how to do the next lines. So to do that one, here's the code. I have dim x as integer and dim y as integer. I want these as variables so that I can actually increment y to move down to the next position for each line. So I have dim x as 125, so that's going to be 1.25 inches for x, and y equals 450, so that's going to be 4.5 inches down from the top of the page. For I equals 0 to 5, that's going to give me 6 lines, 0, 1, 2, 3, 4, 5. I'll say e.graphics.drawString lst paychecks.items.item sub I, so that's going to give me item 0, comma, font mono, remember I want everything to line up, comma, brushes.black, comma, x, comma, y. Then y plus equals 16. So since the font size is 12, I need to add some room for the next line. So as I go down, on the printed page, I'm going to move down 16 points to give enough room for fonts that are 12 points high. If you want more space between each line, you can increment y with a larger number. Or if you want the text to be closer to each other, then you can use a smaller number than 16. How about for doing the next lines? I can use another for loop, and I'll say for I equals 6 through 6, 7, 8, 9, 10, 11, 12. I can do 4i equals 6 to 12 and do something similar. But I have to make sure that the x position is going to be moved over. I need to start off as x being a different value because I'm going to start at a different position on the screen. For example, right here, that is 4.75, which would be 475, and then y, start that off again at 450, and then move down. So for column 2, x starts off at 475 and y again at 450. The for loop has to go from I equals 6 to 12. See how that works out. To test part 2, complete the program and fix any errors that may have occurred. For example, enter employee name, 50 hours, and a pay rate of 60. Click the print preview button to see what the printout should look like on the paper before you actually print. Go back and fix anything to make sure all the lines in their proper position and the text is in the proper position. If it didn't work out right the first time, well, I had to do it several times before I got something that I liked. So don't worry or don't feel too frustrated. I suggest you look at the print preview before you ever do the print because you'll save a lot of paper that way. Well, this is the end of the project. I hope you enjoy it. It should be lots of fun, especially if you actually get a printout that you can go and show people. That is really cool. Have fun. Now you know how to print stuff using Visual Basic.